In 1905, the scientific world was turned upside down by our next great discovery, one of several revolutionary theories put forth by a young, unknown scientist working in a patent office in Bern, Switzerland. His name? Albert Einstein.
Believe it or not,
to find out about Einstein and his discovery, I paid a visit to Michio Kaku, a physicist at the City University of New York.
Einstein once said that all ideas should be presented to children, and if children can't understand it, the theory is worthless. When he was a child, he read a children's book. Electricity was just coming in at that turn of the century, and people were fascinated by telegraph wires. And there's one book by Mr. Bernstein that says, imagine yourself racing alongside a telegraph signal inside a wire. That's where we think, historically speaking, Einstein got his earth-shattering idea, from a children's book.
When Einstein was a teenager, he was inspired by his memory of the children's book to imagine what would happen if he was riding on a beam of light. He pondered that idea for the next 10 years and began thinking about light, time, and space. He realized that Newton's theory that space and time were fixed and absolute did not apply as you approach the speed of light. From this insight, he formulated what he called the special theory of relativity.
In Newton's world, space and time were always separated. If it's 10 o'clock on the Earth, it's 10 o'clock on Venus, it's 10 o'clock on Jupiter, it's 10 o'clock throughout the universe. Time was like an arrow. Once you fired it, it never came back, never deviated. Einstein comes along and says, not so fast. Time is like a river that meanders around stars and speeds up and slows down. Now, of course, if space and time can change, that changes everything. Everything we know about atoms, everything we know about our bodies in the universe changes once time and space also change.
Einstein demonstrated his theory with what he called thought experiments.
The most famous thought experiment is the twin paradox. You get two twins on the Earth, you put one in a rocket ship, send that person off, and of course, that person accelerating near to the speed of light, his time slows down. And so when the two people come together, the twin in the rocket ship is younger than the twin on the Earth. Time beats at different rates throughout the universe.
Depending on what?
Yeah, depending on your velocity. The faster you move, the slower time beats.
Now, we have, in a very small way, done this experiment with orbiting astronauts, right?
That's right. If you have astronauts and send them into outer space, time beats slower on the space station. Time beats slower. That affects all satellites. Look at the GPS satellite. You realize that it's so accurate, you can locate your position to within about, 20 feet of the planet Earth.
You can tell which side of the street you're on.
That's right. So the satellite going around the Earth is going very fast, 18,000 miles per hour. Therefore, you have to include relativistic effects. Now, if the two clocks are out of synchronization, if the clock in outer space runs slower than the clock on the Earth, the GPS system is totally out of whack.
A few months after publishing his special theory of relativity, Einstein followed it up with our next great discovery, the most famous equation ever written.